Hello everyone. Today we're going to look at logarithmic and exponential equations. Now we've looked at some of these types of equations before, but today we're going to look at some very complicated examples. To get started, let's do a quick review of what we know about logarithms and exponents. So first off, we know that if we have a to the b is equal to c, for a greater than 0 and a not equal to 1, and c greater than 0, we can switch from this form to a log form. And the log form is log base a of c is equal to b. Let's also remember, just recall, that whenever we talk about logarithms, we're talking about exponents. So a logarithm is equal to an exponent. So keep that in mind when you work through these problems. Something else is if we have m is equal to n. So we have two things that are equal, maybe two expressions. For m and n, both of them are going to be greater than 0. This is true if and only if a to the m is equal to a to the n. So for example, let's do a quick example. Let's say we had something like x is equal to 3. Then we could say 7 to the x is equal to 7 to the 3. That's something you'll see a lot. So if you have, and most of the time you'll see it in this form and you'll have to go back to this form. So if we had 7 to the x is equal to 7 to 3, then you could say, oh, x is equal to 3 because we have the same base here. Now if we have a different base, then we can't use this property. Also, if m is equal to n, for m and n greater than 0, then this is true if and only if log base a of m is equal to log base a of n. So when you have two things that are equal, you can put a log in the front, but the logs have to have the same base. Also, if you see this in any of these problems where you have a single log on the left side and a single log on the right side and the bases are the same, you can just cross those logs out and you'll get m is equal to n. Finally, let's just look at those properties of where we condense or expand logs, and we have a power rule involving a log. So remember that if we have log base a of b raised to the r, where a again is greater than 0, a is not equal to 1, b is also greater than 0, and r can be any real number. If we have this exponent, we can put it in the front out here. So let me write that like this. This is equal to r log base a of b. So this r is on the outside of the log. We also have that if we have log base a of m times n, where m and n are greater than 0, this is equal to log base a of m plus log base a of n. So remember, multiplication inside a logarithm becomes addition on the outside of the logs. And then also, log base a of m over n is equal to log base a of m minus log base a of n. And again, m and n are greater than 0 for this example here. So division on the inside of a log becomes subtraction on the outside. Okay, I think we're ready to start some problems. Now what I'm going to do is I'm going to show you all the problems that we're going to go over today. So here is the first set. What I would like you to do, I'm going to put some space in between these problems in a few minutes. I just want you to be able to see all the problems. So you should write down each problem and put some space, maybe 3 or 4 lines in between each problem. That way you can work them out. So our first set, here's 1 through 4, and actually maybe I can zoom out a little bit so we can see them all at once. So here are the first 6 problems. We want to solve for x. So take a minute, pause the video, write all of these problems down, and put some space in between each. Then I'll show you the next set. Okay, so once we solve those problems, we're going to have, let's see, I think, is it 6 more? 6 more problems to look at. Again, I'm going to zoom out a little bit. So it says solve for x, and here are the 6 problems. So take a minute, pause the video, put some space between each problem. Okay, and then we're going to look at 2 more problems. And for these problems, we're going to need a graphing utility. So it says use a graphing utility to solve for x. So here are the 2 problems. Again, pause the video and write them down. Okay, so let's go back up to the very first set. I'm going to zoom in a little bit. And I'm going to put some space. So give me just a second and I'll put some space. All right, so let's work on this problem. Now, remember that first rule I talked about. Here we have a logarithm. We want to solve for x. What we're going to do is we're going to switch the exponential form. So again, we have to remember what the base of this logarithm is. If we don't see a base, assume that the base is 10. So I'm going to put a 10 right there. So how we can switch this is 10 to the 1 is equal to x plus 6. So 10 is equal to x plus 6. So subtract 6 and we get 4 is equal to x. Now, you should always double check when you're dealing with logs. Remember that whatever you put inside of a logarithm, this x plus 6, it has to be greater than 0. So when you solve for x, the number, say x plus 6 has to be greater than 0. So x has to be greater than negative 6, which our answer was 4, which is greater than negative 6, so we don't have to worry about it. But sometimes when we do these problems, we'll get something outside of the domain. So we'll have to get rid of what we found. But for this particular example, 4 works. So again, always double check, and you can plug in that 4 here, you'll get 10, and we know that log base 10 of 10 is equal to 1. Here's the second problem. This should look similar to a rule we just wrote down a minute ago. Maybe pause the video and see if you can solve this one. Okay, so we have log base 5 of 2x plus 3 is log base 5 of 11. So this is similar to that log a of m is equal to log a of n, and then we said that m and n would be equal. So we're going to set 2x plus 3 equal to 11. Just move the 3 over. So we get 2x is equal to 8. So x is equal to 4. This is a positive number. If we plug it in here, we're going to get something positive. So it will work for this log. And if you plug it in, you'll see you get 11. So the left-hand side is the right-hand side. Okay, now that we're getting into more complicated examples, the last 2 examples are some things that we've seen before. Let me tell you the strategy for when you have these types of problems where you have some logs. So let me write this down. This is your strategy here. You want to rewrite your problem in a couple of ways. You're going to either get log base a of b is equal to c. So you want to get just one log on the left-hand side equal to some number, or log base a of b is equal to log base a of c. It really depends on what you have. For this example here, on the right-hand side, I just have a number. Sometimes you'll have logs for everything, okay? When you have logs with everything, you're going to go with this step here. But for this particular example, we're going with this one. So remember, what I want to do is I want to condense, put everything together so I have one log, just one log, and I want it to be on the left-hand side, and then on the right-hand side, I want either just one log or some number. So that's what we're going to do. You can see that this problem You have a subtraction sign and you have a power. So we're going to use those rules of logs to condense this into one log, and we're going to get it in this form here. Okay, so let's do that. So maybe pause the video and see if you can condense this, and then we'll go from there. After you condense it, unpause the video and look and see if we get the same answer. So this is log base 3 of x plus 4 squared minus log base 3 of 9 is equal to 2. You have a few options here. Everybody, might see something different when they do this problem, and that's fine. I'm going to show you a second way to do this problem. But right now, what I see is I see a subtraction sign, and I know that that becomes division. So this is x plus 4 squared over 9. So it becomes division on the inside of a log. And now you see that I have that special form where I said log base A of B is equal to C, where this was my A, this is my B, and this is my C. So again, I'm trying to get just a log on the left-hand side and a number on the right-hand side. Okay. When I have this, then I can switch it back to my exponential form. So after we get it into that form we wanted, we're going to switch to exponential form. Okay, so how do we do that? That's 3 squared is equal to everything on the inside. So we have 3 squared is equal to x plus 4 squared over 9. So this 3 squared is 9. So we get 9 is equal to x plus 4 squared over 9. Let's get rid of that 9 by multiplying both sides by 9. So if we do that, this will just become 81 is equal to x plus 4 squared. So what can we do from there? Well, we can take the square root of both sides. Now remember, when you take a square root, you get a positive and a negative square root. So let me flip this so that it looks like x plus 4 squared is equal to 81. So taking the square root, I get x plus 4 is equal to plus minus square root 81, which the square root of 81 is just 9. And then subtract 4, so we get x is equal to negative 4 plus minus 9. So we're going to get two answers. We're going to get x is equal to 98765, or x is equal to 9, 10, 11, 12, 13. So we're going to put negative 13. So we have two numbers, 5 and negative 13. Now we're going to double check these. So I'm going to erase. And now I'm looking back at the original problem. So this is where we started. And remember what we did? We put the 2 here, and then we made it division and set it equal to 2. I'm going to put these numbers into this log here. And then I want to see, first off, if I get any negatives in the domain. If I do, I throw these numbers away, or throw one of them away. And also, I just want to see if I get the right answer, because it's always good to double check your work. So if I plug in this negative 13 here, I'll get negative 9, which we can't have negative 9 inside a log. Remember, whatever's here has to be greater than 0. So we're going to throw this one out. Now let's plug in 5. If I plug in 5, I get 5 plus 4. So this is 2 log base 3 of 9 minus log base 3 of 9 is equal to 2. Is that true? Well, we're going to put this 2 up here like we did before. Okay, let me put a little space here. So what I'm doing is I'm checking to see if the left-hand side is equal to the right-hand side. So I'm trying to simplify a little bit. There's a few ways to simplify this. How I'm going to simplify it. So I'm going to follow what we did earlier. So this is log base 3 of 9 squared over 9. Is that equal to 2? Well, 9 squared over 9 is actually just 9, so I can put that here. And is 3 squared equal to 9? So switching back to the exponential form, this is the same as asking is 3 squared equal to 9? Because you can evaluate this logarithm. Log base 3 of 9 is 2 because 3 squared is 9. So the answer is yes. So you can see that our answer worked. So this is the answer to the problem. X is equal to 5. I did want to mention that there was another way to solve this problem, just in case, you might see something different. Everybody sees different things when they look at a problem. So the first thing we did was we wrote this as log base 3 of x plus 4 squared minus log base 3 of 9 is equal to 2. And right here immediately you could simplify this log because log base 3 of 9 is 2. So this would be log base 3 of x plus 4 squared minus 2 is equal to 2. I'm just simplifying this log. And then move the 2 to the other side. Okay, and now we can switch this into exponential form. Again, when you get to this step where you have a log on the left-hand side and a number on the right-hand side, switch it to exponential form. So this is 3 to the 4th is equal to x plus 4 squared, and 3 to the 4th is 81. So we got exactly what we did the last time, and then we would just continue the steps we did earlier. Okay, let's move on. Okay, this time I have log base 10, because I don't see a base, so it's assumed to be 10, of 2x minus 1 is equal to log of x minus 3. We're going to follow that same strategy. So the first step is to get a log on one side and a number on the other side. So rearrange this and combine what you can to get a log on the left-hand side and a number on the right-hand side. So pause the video, see if you can move things around and condense logarithms. Okay, so this is the same thing as log of 2x minus log of x minus 3 is equal to 1. I moved this one over and I moved this one over. So I added 1 and I subtracted this log. From there, I can combine these two logs. This is log of 2x over x minus 3 is equal to 1. And I'm going to put this base here. This is base 10. Okay, now that we have gotten to this point, now we switch to the exponential form. So this is the same thing as 10 to the first power is equal to 2x over x minus 3. So in other words, 2x over x minus 3 is equal to 10. Okay, now I want to solve this rational equation. To solve this, the first thing I have to notice is that x cannot be 3. Why can't it be 3? Because if it was equal to 3, if I put 3 in the denominator here, I'm going to get 0, and I can't divide by 0. So when I solve this, if I happen to get the number 3, then I'm going to throw it out. Because if I get 3, then I wouldn't actually be able to plug into the equation. What you can do to solve this is you can multiply both sides by x minus 3. So we get 2x is equal to 10 times x minus 3, or in other words, 2x is equal to 10x minus 30. And then from there, we can move the 10x to the other side. So we get negative 8x is equal to negative 30. And x is equal to 30 over 8, which we can simplify. So this is equal to, if we divide by 2, we'll get 15 over 4. So let's leave it like that. X is equal to 15 over 4. Again, we're going to double check. So we're going to look back up here. Give me just a second to erase some stuff, make it less cluttered. Okay, so if we look back at our original equation here, first off, we're going to check and see if we can plug this into our logs. Now this is a positive number, and I have 15 over 4. If I multiply it by 2, I'll get 15 over 2, which is positive, so that log is fine. Now how about this one? 15 over 4 minus 3. Well, 3 is the same thing as 12 over 4. So that would be, I would be left with 3 over 4, and that's a positive number if I subtracted these, so that's fine. Okay, so from there, let's plug it in to see if we actually get a correct solution. And also 15 over 4 is not equal to 3. Remember, 3 is 12 over 4, so we're okay because we can plug that in this denominator. So log of 2 times 15 over 4 minus 1, is that equal to, we said that this was log of 3/4. So this is log of 15 over 2. I'm going to move this to the other side, so this is minus log 3/4 is equal to 1, sort of like what we did earlier. And this is log, let's put the base 10 here, of 15 over 2 divided by 3 over 4. Is this equal to 1? So let's see. 15 over 2 divided by this 3/4 is the same thing as 4 over 3. So 2 goes into 4 2 times, and 3 goes into 15 5 times, and 5 times 2 is 10. So this left-hand side simplifies to log base 10 of 10. And remember, 10 to the first power is equal to 10, so this does equal 1. Okay, let's go to the next problem. Here I have log base 2 of x plus 1 plus log base 2 of x plus 7 is equal to 3. Okay, pause the video, put these logs together, and then switch to exponential form, and I'll meet you there. Okay, so you can see that I took this addition and made it multiplication inside the log, and I actually FOILed these two to get x squared plus 8x plus 7, and then I switched to exponential form, so I got 2 cubed is equal to this. And from here, what I'm going to do is I'm going to make this an 8, because 2 cubed is 2 times 2 times 2, so that's 8 is equal to x squared plus 8x plus 7, and now I want to solve for x. And this is a quadratic. To solve for x, we're going to move everything to one side, so we get 0 is x squared plus 8x minus 1, and then we're going to see if we can factor it. I don't believe this is factorable, so what we're going to do is we're going to use a quadratic formula. So recall the quadratic formula is x is equal to the opposite of b plus minus square root b squared, 64 minus 4 times a times c, all divided by 2 times a. So we get that x is equal to, put some space down here, is equal to -8 plus or minus. This is going to be a positive 4, so we get the square root of 68 over 2. This square root 68 is the same thing as the square root of 4 times the square root of 17. So we can write this as x is equal to -8 plus or minus 2 square root 17 over 2. And then from there I can divide that 2 into everything. So I'll get x is equal to -4 plus or minus square root 17. So I'm getting two answers. I'm getting -4 plus square root 17, and also -4 minus square root 17. So this -4 plus square root 17, well, square root 17 is about 4.123. So if you add -4 plus the positive version of this, you're going to get about 0.123. And if you subtract them, you're going to get about -8.123. And the reason I'm figuring these out, trying to get an estimate, is notice that this one is negative. So we're going to have to look back at the original problem and see if we can plug it into the logarithms. Okay, you can see that for the first one, let me erase this. Now remember, this part is what the square root of 17 is, or about what it is. So let's look at this -8.123. I can't plug that into here, because if I add 1 to it, I'm going to get a -7.123. So I can't have negatives in logs. So we're going to have to throw this answer out. This 0.123, I can plug it into here because I'll get 1.123 and I can plug it into here. So this is a possible answer. It is actually one of the answers. Let's see if we can double check this. You know, sometimes it would be difficult. You're going to find that you're going to get a problem, especially if you have square roots. It's going to be difficult to double check, but it is possible. I'm going to double check it. So if we plug this in, let's see what we get. Is log base 2 of -4 plus square root 17 plus 1 plus log base 2 of -4 plus square root 17 plus 7, is that equal to 3? So this left-hand side simplifies to log base 2 of -3 plus square root 17 plus log base 2 of, this becomes +3 plus square root 17. Is that equal to 3? I'm just following what we did before. We can multiply these two, so we get log base 2 of -3 plus square root 17 times 3 plus square root 17. Is that equal to 3? Well, notice what happens if we multiply the inside. We'll get a log base 2 of a -9. We'll get a -3 root 17 and a +3 root 17, so those cancel. And then root 17 times root 17 is just +17. Is this equal to 3? Adding these together, you get log base 2 of 8. Well, log base 2 of 8, 2 to the third is equal to 8. Remember, a logarithm is the exponent, and that is 3. So we double checked, our answer does work. Okay, here's the last problem in that set. We have ln of x plus ln of x minus 2 is equal to ln of x plus 4. So this is an example of where we have logs for everything. Now, I mentioned that our strategy, we had two strategies. We can get log base a of b is equal to c, or log base a of b is equal to log base a of c. Okay, so for that, we can look at this one and we can see because we don't have a number, we're going to go with this one. However, you can also go with this one if you move this log to the other side and you get 0 here. So it's up to you. I particularly like this strategy. I can do it both ways. In fact, I'll just at least get you started on the other way. So we're going to go with this strategy here. And then what we're going to do once we get to here is we're just going to cross these logs out, and then we'll have b is equal to c. So combine whatever you see on the left-hand side into one log, and if you see some stuff on the right-hand side, you want it to be just one log. So for our particular example, let me get rid of this. You can see that on the left-hand side, we get ln of x times x minus 2, because this is a plus, and then we get ln of x plus 4. So now that we have log on the left-hand side, just one, and one log on the right-hand side, we can cross these out, and we get x times x minus 2 is equal to x plus 4. So we're going to distribute this x. We get x squared minus 2x is equal to x plus 4. We have a quadratic, so let's move everything to the left-hand side. We get x squared minus 3x minus 4 is equal to 0. Try to factor it. I believe it factors. This is x minus 4, x plus 1 is equal to 0. Just double check real quick. So we get x is equal to 4, or x is equal to -1. Again, when we get to this point, we need to double check our answers. First, to see if they can even go into the domain. And then also, we need to see if we did our math correctly. So if we put in 4, notice that we don't have any problems in the domain, but if we plug in -1, I can't put a -1 in this log or in this one. So we're going to have to throw this one out. So this is the only possibility. You got ln of 4 plus ln of 4 minus 2, which is 2. Is that equal to ln of 4 plus 4, which is 8? Well, this multiplies to give us 4 times 2 is 8. So this is ln of 8, the right-hand side. So I combine the left-hand side to get the right-hand side. Okay. Now I wanted to show you that there was another way to do this. And what I mentioned was to move everything to the left-hand side. So you get ln of x plus ln of x minus 2 minus ln of x plus 4 is equal to 0. And then combine all of this, which will be x times x minus 2 over x plus 4, ln of this, is equal to 0. And then you can use that property where you switch back to an exponent. So exponential forms, because this is base e, so this e to the 0, which would be 1, is equal to what's inside. I think this way is a little more complicated than what we did before, but you'll still get the same answer. Okay, let's work on these. So give me just a minute to put some space in between them. Okay, so here is our first problem. 5 to the negative x is equal to 25. Now we've done this type of problem, so this should be a real review for you. Remember, if we have a to the m is equal to a to the n, then we say that m is equal to n. That's what you want to do here, except for you can see that this base and this base are not the same. This is 25 to the power 1, but you can write this as 5 squared. So this is 5 to the negative x is equal to 5 squared. And because that's true, you get negative x is equal to 2 or x is equal to negative 2. And plug that in, you see that negative of negative 2 is positive 2, so you do get 25. Okay, for this problem, you have 3 to the x is equal to 14. It would be nice if we could write 14 in terms of 3, but we can't. There's no way to write the bases, get the same base. So what you do in this case is you use logs. And in fact, you could use it in the last case as well, but we're going to use logs, and you can choose whatever log you like. My favorite log is the natural log. So what I'm going to do is I'm going to put natural log in front of both of these. Now remember, we had that if m is equal to n, then we could put log base a of m is equal to log base a of n. And that's what I'm doing here. So I'm going to say ln of 3 to the x, this is log base e, is equal to ln of 14, because these two things are equal. So this one's m and this one's n. And from there, what I can do is I can pull this power, put it in the front. I get x ln of 3 is equal to ln of 14, and then I can divide. So I get x is equal to ln of 14 over ln of 3. And that's my answer. Now, your homework will probably ask you for an exact answer. This is what you're going to type in if it wants an exact answer. Of course, you can use any log you want to. You could have log base 10 of 14 over log base 10 of 3, or log base 8 of 14 over log base 8 of 3. I'm just using natural log. You're going to get the same answer no matter what you do. But let's see what we can get as a decimal approximation. So I'm going to switch over to a graphing calculator. So give me just a second here. Let me do a new share. There we go. So here I'm going to put ln of what we had, which was, scroll down, 14 over ln of 3. So ln of 14 divided by ln of 3 is about 2.402. I'm going to round it to 3 decimal places. And let's just check and see if that's about right. So the problem was 3 to the x is equal to 14. So let's see. 3 to the 2.40217350273. You can see that I get 14. Okay, so let's go back. So x is about 2.402. go to our next problem. Okay, so we have 4/3 raised to the 1 minus x is equal to 5 to the x. Whenever you can't make the bases look the same and you have x in the power, what you're going to do is take the log, whatever log you like, of both sides, and pull the powers down. So that's what we're going to do here. So we have ln of 4/3 to the 1 minus x is equal to ln of 5x. Now pull the 1 minus x in the front because it's a power. And then pull this x in the front. And now what do? We need to get the x by itself. Okay, so our job is to get x by itself. Maybe take a minute and put some space, sorry about that. Take a minute and think about how you can get something with x and anything without an x. So get whatever has an x on the left-hand side and things that don't have an x on the right-hand side. Okay, so what I'm going to do is I'm actually going to distribute here. So this is the same thing as ln of 4/3 minus x ln of 4/3 is equal to x ln of 5. I'm going to move. It doesn't matter if you move. I think I usually like the x on the left-hand side. So what I'm going to do is I'm going to put this over here and I'm going to move this to the other side. So I get negative x ln 5 minus x ln of 4/3 is equal to negative ln of 4/3. Do you see what I did there? I also want to change all the signs because I have so many negatives. Let's multiply everything by a -1. So everything will become positive. Now, why did I do this? Now I can factor out the x on the left-hand side. This is x ln of 5 plus ln of 4/3 is equal to ln of 4/3. From there, I can solve for x by dividing by this piece. So x is equal to ln of 4/3 divided by ln of 5 plus ln of 4/3. Now you have some options. You can leave it just like this. This is a correct answer. You could also combine the ones on the bottom. So this is also equal to ln of 4/3. And on the bottom you have ln of 20/3. Now you can't combine these two because remember it's subtraction on the outside of a log becomes division on the inside. But here you have division on the outside, so you can't combine them. But you could combine these two on the bottom. So either one of these is correct. Let's figure out a decimal approximation for this. So let me write this down so I don't have to switch back here. 4/3, 20/3. Okay, so let me go over to my graphing calculator. I'm going to put ln 4/3 divided by ln of 20/3. This is about 0.15. And then let's see what our original problem was. So let me go back. So let's see if we put 0.15 into here. So I'm going to write this out. 4/3 to the 1 minus x is equal to 5 to the x. Let's see if the left-hand side will equal the right-hand side. So we're going to do this in the calculator. Okay. So on the left-hand side, we had 4/3 to the 1 minus, and I'm going to just write all these decimals out. So 0.151641474837, and the other one was 5 to the 0.151641474837. You can see we're getting the same answer. So this is the correct answer for this problem. Okay, let's go back. Okay, so x, we said x is about, you can say this, and if I asked you for a decimal approximation on your homework, you can say, oh, it's about 0.15. Okay, here's problem number 4. All right, I want to do something very similar to what I did before, where I just put an ln in the front. There's many ways to do this. You could just go ahead and put an L in the front of this. What I'm going to do, and it's going to make my life easier, is if I divide everything by 0.3, because then I'll have 4 to the 0.2x is equal to 0.2 over 0.3. And then from there, take the ln of both sides. So ln of 4, 0.2x, is equal to the ln of 0.2 over 0.3. And then pull the 0.2x in the front. So let's do that. And then we're going to get rid of anything that's not an x. And how we do that is we divide by this 0.2 and this ln of 4. So we get x is equal to ln of 0.2 over 0.3 divided by 0.2 times 4. So let me write it like that. I think this is kind of not pretty. I don't like these decimals here. Notice that 0.2 over 0.3, if we multiply the top and the bottom by 10, it's the same thing as ln of 2 over 3. And we can clean this one on the bottom. This is just 0.8. So that looks a little bit better. So this is the answer. And you can find the decimal approximation. I'm not going to check that. That's something you can do, and then you can also check to see that it works in this problem. Let's move on. All right, this one's a very interesting problem. And actually, this is something that we're gonna have to do something a little creative for this problem. What I'm gonna do is I'm gonna move everything to the left-hand side. So I get 3 to the 2x plus 3x minus 2 is equal to 0. And if you didn't think about doing that for this problem, that is completely okay, because this is something that I usually don't expect a student to see right away. But once you see it, you should notice it in the future for similar problems. Okay, notice that this 3 to the 2x is the same thing as 3 to the x squared plus 3x minus 2. Do you agree with that? Is 3 to the x squared the same thing as 3 to the 2x? Remember, you just multiply these two. So the answer is yes. Now what happens if we let the letter u be equal to 3 to the x? Well, we'll get u squared plus u minus 2 is equal to 0. Why is that helpful? Well, now we have something that looks like a quadratic. I have u squared plus u minus 2. And if we pretend like u is x here, we can factor it. So this is the same thing as u plus 2 times u minus 1. Double check that. Let's square it. U squared, negative u plus 2u makes a positive u, and then a negative 2. And so when we have something like this, we say u plus 2 is equal to 0, or u minus 1 is equal to 0. So u is equal to negative 2, or u is equal to 1. Okay, let's just recap what we did here. So we had this equation. We moved the 2 to the other side. And then we wrote this 3x as 3x squared. And then we used u substitution. So we said u is equal to 3x, because when we did that, we got something that looks like a quadratic. And then we factored that quadratic, and we got u is equal to negative 2, or u is 1. But we're not looking for u, we're looking for x. That's the goal, to solve for x. So what do I do to find this x? Well, I substitute what u is. So since u is 3x, I get that 3x is equal to -2, or 3x is equal to 1. And now I need to solve for x from this piece. Okay, the left one is going to have no solution because you can't have 3 raised to a power and get -2. Whenever you raise, like if you have an exponent on the left-hand side, you're going to get a positive number. So just remember the domain and the range for this type of function. For this side, we can actually use logs here. So if you take the, you can choose any log you want, but I like like I said, the natural log. You'll get ln of 1 like that. Pull the x in the front, you get x ln of 3 is equal to ln of 1, and then you can solve for x. You get x is equal to ln of 1 over ln of 3. And actually, we can find this value because ln of 1, remember what that is. So this is log base e of 1. So e to the power what gives you 1? Well, that's 0. So this is 0 over ln of 3. So in other words, x is equal to 0, which makes sense because if I plug in 0 here, 3 to the 0 is 1. So this is the value for x. Let's double check. So let's go back to the original problem. What happens if I put a 0? I get 3 to the 2 times 0 plus 3 to the 0. Is that equal to 2? Well, this will be 1 and this will be 1 and we'll get 2. Okay. This one's going to be similar to the last problem, although at first sight it might not look similar. But maybe you can pause the video and see how you can make this problem kind of look like the last problem. See if you can get like a 2x involved, and so you can have like a u squared, something. Remember that a quadratic looks like ax squared plus bx plus c. Maybe you can get an au squared plus a bu plus c. So take a minute, see if you can figure that out. All right, so what do we have here? I'm going to move the 16 to the other side. I get 25x minus 8 times 5x plus 16 is equal to 0. This 25x is the same thing as 5 squared. So this is 5 to the 2x minus 8 times 5x plus 16 is equal to 0. And now we're going to use this u substitution. I'm going to let u be 5x. By doing that, I get u squared, because this is 5x squared, like we did before, minus 8u plus 16 is equal to 0. Can we factor this? I believe we can. This is u minus 4 times u minus 4 is equal to 0, and you get u is equal to 4. But u is 5x, so 5x is equal to 4, and then you're going to do that log trick. So you get ln of 5 with the x in the front is equal to ln of 4, and then divide by ln of 5. And that is your answer. Okay, we have 2 more problems I want to look at before we end this video. We want to use a graphing utility to solve for x, and the reason being is that none of the tricks that we saw before are going to work. Why? Let's just try it for the first one. So maybe if we take the ln of both sides, so we get ln of e to the 2x is equal to ln of x plus 2. The problem with this is we have x inside the natural log, and I don't want that. Whenever we were solving these problems, we had x's on the outside, and we were able to solve for x. So to get this x outside of this log, we would have to switch back to an exponent. But then if we do that, we're going to have an x in the exponent, so we can't really do anything with that. Similarly with this one, if you try to get rid of this log, notice that you have x on the outside. When I showed you some tricks for this, we only had a number on the outside without a log. We never had just an x involved. So you won't be able to get anywhere using the tricks I've shown you. But what we can do is we can think about this in terms of graphs. You can think of this as the function e to the 2x. So maybe we can even have an idea of what this looks like. So starting with this first problem, maybe we can give a little sketch of the graph. So let's say y is equal to e to the 2x. Well, that looks something like this. E to the x looks like this, and this is just 2 with the x. So we multiply all of our x's, we're stretched the graph, remember. So we're going to multiply each x value by 2, so the y value changes. So this would be the function y. And then g, we can say g of x is equal to x plus 2, this guy here, which is the equation of a line. So let's graph that. Okay, notice that this point right here, this is the point 0, 1, because if we plug in 0 here, e to the 0 is 1. And x plus 2 is a line that goes through 2 and has a slope of 1, so it's going to look something like this. So to solve this, all we have to do is find where these two graphs intersect. And we can do that by using a graphing utility. So let's plug this into our graphing calculator. Okay, so I'm going to show you what this looks like. So you can see this black graph right here. This is e to the 2x, this black one. And this red line is x plus 2. And you can see that we cross right here. Let me write this down on my paper. X is equal to 0.448. And the y coordinate is 2.448. And also right here at negative 1.981. And y is 0.019. So let's try to interpret this. The x value is what we're looking for. So we got two x values, 0.448 and negative 1.981. So remember what we had. We had e to the 2x is equal to this x. Let me write it like this. E to the 2x is equal to x plus 2. That was, don't worry about the graph. I just wanted to write out the equation so you could see it again. This was the equation we were given. So let's see what happens when we plug those two numbers in here. So I'm going to start with e to the 2x. When we plug in that first number, let's with 0.448, we get 2.4497, which is exactly what we got for the y coordinate. That is the y coordinate here, 2.448 is rounded. And then if we plug that into x plus 2, so 0.448 plus 2. Again, this is a rounded number here, but you can see that we're getting about the same thing here. Okay, and then let's try the other number. So the other number, you can see they cross at negative 1.981. So if I plug in negative 1.981, this is a rounded number, this is going to be rounded. If I plug it into here, negative 1.981, you can see that they're about the same. So these two values, these x values, when you plug them in, you're getting that these two functions are equal. Okay, so let's go back. So we said that the x values that work are 0.448, about that, and x is negative 1.981. Okay, maybe you tried this one. You could even try to get an idea of what the graph looks like just by sketching it on your own, and then put it into a graphing calculator and find the x values that work here. All right, so I'm going to share my screen. Here, the purple graph is ln of 2x, and the black graph is negative x plus 2. And you can see that they cross at x is equal to 1.159 and y is equal to 0.841. So there's only one answer for x this time. So let's write that one down. So let me go back. So our value for x is 1.159.